So let's jump right into today's notes, 6.3, graphing square root functions. And let's begin by graphing the old school way with the input-output table. And we will be graphing the most basic type of square root function, y equals the square root of x. And let's use an input-output table. The beauty of an input-output table is you could use any numbers you want to plug in. So what number would be nice to plug in? What's an easy number to plug in? 1 is absolutely easy. When I plug in 1, what do I get out? What's the square root of 1? 1. So when I plug in a 1, I get out a 1. What other number is easy to plug in? 0. Absolutely. 0 is one of the easiest. When you plug in 0, you get out a 0, right? We all agree that the square root of 0 is 0. So we did 0, 0. We have 1, 1. What else?
2.
2? Let's think about that. If I do the square root of 2,
4.
that's not a nice answer, right? The square root of 2 is not a nice answer. So let's not use 2, okay? 4. 4 will definitely be great because when I plug in the 4, the square root of 4 is 2, okay? And what else? What else could I plug in?
3.
3? What's the square root of 3?
9.
9. 9 would be great, right? 9 would be great because the square root of 9 is 3. So, of course, when you have a perfect square, or not a perfect square, a square root function, you want to plug in perfect square numbers, or 0. That way you end up with nice, perfect answers. Now, that doesn't mean that you cannot plug in 3. I mean, you could plug in 3, but that's going to give you an irrational decimal, which will be kind of hard to show on the graph. So anyway, let's graph these. 0, 0 is right here. 1, 1 is right here. 4, 2, 1, 2, 3, 4, 1, 2 is right here. 9, 3, it's all the way, since this is a 10 by 10 graph, 9 is right here, 1, 2, 3 is right there. And this is our graph starting at 0, 0, going up in this direction forever, okay? Now, notice that the graph does not exist at the x value of negative 1. Why not? Because if I did plug in a negative 1, what's the square root of negative 1? It's I, it's imaginary, so it's not real. You could graph I on a complex plane, but this is a real xy plane. So that's why plugging in negative 1 would not work, right? It's no good. Because if you plug in a negative 1, you're going to end up with imaginary. So this graph truly does begin right here at this point, 0, 0, and it does continue to go up and to the right forever. Okay? Even though it looks like it tops off, it never completely tops off. You're going to continue to go to the right and up forever. I mean, like I said, we could plug in 16. The square root of 16 would go up to 4, right? If you did the square root of 25, it would go up to 5. So the y values continue to rise forever, just like the inputs could continue to grow also forever. The square root of 100 is 10. So if I went 100 this way, I'd be 10 up. Make sense? Everybody with me? Okay. So that's the parent graph. What do you think would happen if you have a negative sign out here in the front? What do you think would happen based on our previous knowledge on graphing? If you took the square root of a negative, yeah, but this is a negative out in front. Like the a value is negative. Okay, how about this? Let's not, I mean, I just wanted to see if anybody got it right off the bat, but let's actually do an input-output table again for this new function, y equals negative square root of x. That's really saying that your a value is negative, and I hope we remember from semester 1 that the a value tells you if the parabola opens up or down, right? But in this case, we don't have a parabola, we have a square root function, which starts at a certain place and shoots off in one direction. So anyway, let's actually plug in the values that work. What would be a nice number to plug in to a square root? 0, right? The square root of 0 is 0, but when I plug in 0 right here, the square root of 0 is 0. With the negative in front, it's negative 0, which still happens to be 0. All right, what if I plug in a 1 right in there? The square root of 1 is 1 with the negative in front. That will be a negative 1. Whoa. Negative 1. If I plug in a 4 right in here, the square root of 4 is 2, but with the negative in front, that would be a negative 2. If I plug in a 9, the square root of 9 is 3, but with the negative in front, that would be a negative 3. Are you guys following me? Okay. So let's graph these coordinates. 0, 0, 1, -1, 4, -2, and 9, -3. As you could see, you should see this graph that begins at 0, 0 and shoots off in this direction. Compare that to the original parent graph. This guy starts at the origin and goes up and to the right. This one starts at the origin and goes down to the right. So it really does get reflected over that x-axis. You guys remember that from parabolas? Yes? No? Anybody? So like if we had, let's go back to last semester. If we had y equals x squared, well, that would look like the regular U-shaped curve that has the vertex at 0, 0. You guys remember that, right? And if for some reason I would change it to y equals -x squared, if you had the a value that was negative, that would cause a reflection on the x-axis. You guys remember that? So it's the same deal here. If the a value is +1, it's going to be a regular, not U-shaped curve, but a regular square root curve from here going off that way. And if the a value becomes negative, it simply gets reflected over the x-axis. This coordinate gets reflected down to here. This one gets reflected down to here. This one gets reflected down to here. That's how you end up with this new one that gets reflected over the x-axis. Yay? Okay. And we also had some other tricks that we had when we graphed parabolas. How about this? Let me review vertex form parabolas. Y equals a parentheses x minus h squared plus k. You guys remember that from semester 1, graphing parabolas? I hope so. If you don't, man, we're going to have some problems here. The a value told us if the parabola opened up or down, right? The a value also told us if it was a vertical stretch or a compression, if it got wider or if it got narrower, right? The further it is away from 0, the more stretched it got. The closer it got to 0, the more compressed it got. You guys remember that? Okay. So if you had a 1/10 right here, it'd be a really wide parabola. Really wide parabola. If it were 2 or 3, it'd be a pretty narrow parabola. Okay. The h was the coordinate or the vertex that ultimately shifts your parent graph h units to the left or right, depending on what this is, and you have to think opposite on h. And the k value was a shift up or down, and you take that value for what it is. The h value was always inside parentheses being subtracted from x, and the k value was always being added or subtracted at the very end. So if we remember semester 1, graphing parabolas, we should do pretty well on graphing square root functions. You see right here, the a value is the number that's out in front. What's the a value here? 1. What's the h value? It's the number that's inside parentheses being subtracted from x. But now instead of parentheses, we have a square root. Is there being something subtracted from x inside the root? Not really, because this -2 is outside the root. This -2 is the number that's being subtracted or added at the very end. So what is your h value? It's the number that's being subtracted from x inside the square root. There is nothing being subtracted from x inside the square root. What's the k value? -2. So we know that we need to get some coordinates of the parent graph, and it's ultimately going to shift nowhere to the left or right, but it's going to shift 2 units down. Okay? So the trick to graphing these guys is to identify your h and k, and that's what we did. Here's our h, here's our k, and then ignore h and k. And I ignore h and k by putting a box around the function without h and k. Which, what is this? It's our parent graph. It's the very first graph that we did. And it's pretty easy to get some coordinates to the parent graph. The coordinates would be, what would be nice to have inside a square root? Well, the square root of 0 is 0. The square root of 1 is 1. The square root of 4 is 2. And the square root of 9 is 3. It's the same coordinates as our parent graph. So if we were to graph these coordinates, 0, 0, 1, 1, 1, 2, 3, 4, 2, and 9, 3, those are the coordinates but of the parent graph, not of our real graph. It's of our parent graph. Where's our real graph going to be at? You got to take these coordinates and shift them where? 2 units down. right? There is no H, so you don't move left or right, but you do move 2 units down. So every single one of these blue dots needs to get shifted 2 units down. Let me put it in red here. The red dots will be the final graph. 2 units down, 2 units down. You guys see that? Every single blue dot got shifted 2 units down. 2 down, 2 down, 2 down. So let's say you accidentally did the blue dots. Let's say you accidentally put that graph of the parent graph. What should you do? Put 2 X's on it. That way I know that that's not your real graph. Where's your real graph at? Those red dots. So this guy down here is the real graph. Are you with me?
Do you want to see both of them?
I just need to see the final graph that has the H and K shift, right? So this is the one I want to see. Okay. So if you accidentally drew the original, the parent graph, go ahead and put some X's on it. That way I know that that's not the right graph. In addition to graphing, we need to be able to state what we stated before on parabolas, the domain and the range, right? So let's look at this first parent graph. Like we said, the domain are your X values. Does this go to the left and to the right forever? Only to the right. So where does the graph start at? What X value does it start at? At 0, and it's going that way. So how do I say in terms of an inequality, to state our domain, what would I say? The domain is X is what? Greater than or equal to, it's going to the right. What value? The 0. How about the range? The range are your Y values. Does this go up and down forever? No. Where does it go? From here. It goes up. Does it ever stop growing up, or does it continue to slowly go up forever? Slowly go up forever. So what am I going to say that from 0 and above? How do I say that in terms of an inequality?
Y is greater than 0.
Greater than or equal to 0, right? You include the 0 because it actually does start right there at the Y value of 0. Okay? So since we already graphed these other ones, let's give these a domain and range also. The final product, that is, not the parent graph. So the domain right here would be X is what?
0.
X is, here's 0. Is it to the left or to the right? It's to the right, so it's greater than or equal to 0 as well. How about the range? Y is what? Less than or equal to what? 0. Okay, that's pretty easy. All of these beginning points on these first two have been at 0, 0. This one's where it starts getting a little interesting. What's the domain on this guy? X is what? Greater than or equal to 0, right? Let's talk about this beginning point and what that X value is. What's that X value? 0. And does this graph exist at -1? No. Does it exist at +1? Yeah, it's right there. At +2? Yeah, it's right there. +3? Yes. 4? Yeah. So it's from 0 on the X going this way forever. That'd be X is greater than or equal to 0. How about the range? The range should be your Y values. And what Y value does it begin at? At -2. Now, is it above -2 or below -2? The whole thing is at -2 or above. So what do we say?
Y is
Greater than or equal to -2. So I hope we could conclude this. We should conclude that similar to vertex form parabolas, quadratic equations, here's the function notation or the function form of a square root. The A value will tell you if it opens up or down. It tells you if it's vertically stretched or compressed. The H value is always going to be in parentheses, just like on parabolas, but in this case inside the square root instead of parentheses. You always think opposite of what you see here. The K value is always the number that's being added or subtracted at the very end. You take that for what it is. And we should know that H is the left and right shift. The K is the up and down shift. So let's jump to one of the more challenging ones. Let's say this guy right here. So how am I going to, actually let's jot down some steps on how to graph these just to make it a little easier for us. Maybe you want to jot it down here somewhere. So let's say step 1 is to identify H and K. Now, this is going to sound weird, but once you identify h and k, let's say ignore h, k with a box. And once I explain, once I show you this, it'll be easy to understand. And then step 3, shift your coordinates. So you ignore h and k with the box and graph. I'm sorry, I should have put and graph. And then shift your coordinates with h and k according to hk. Let's go back up to here. And step 1 says identify h and k. Tell me what h is.
2.
It's not 2. It's negative 2. You got to think opposite on h. What's the k value? Negative 3. You take k for what it is. Think opposite on h, take k for what it is. Now, what does this actually mean? That once you have coordinates, you're going to shift them 2 to the left and 3 down. So down there on those like sloppy notes that I wrote, step 1 was to identify h and k. We just did that. Step 2 is to ignore h and k with the box. Notice that I put a box around the function without the h and the k. The h is on the outside of the box, k is on the outside of the box. So technically, I'm ignoring these guys, and I'm pretending to only have the parent graph. Yes? Now, I mean, we actually do have it, but I'm pretending that the h and the k are not there. I'm ignoring h and k just for a little while. Why am I ignoring h and k? Because it's really easy to come up with the input-output table for that parent graph, y equals square root of x. What's the square root of 0? It's 0. What's the square root of 1? It's 1. What's the square root of 4? It's 2. What's the square root of 9? It's 3. So these are the parent graph coordinates. 0, 0. Let me put that dot right here. 1, 1. It's right here. 4, 2. 1, 2, 3, 4. 2 right there. And 9, 3. 9, 3 is up there. Now, these are the coordinates of the parent graph. So I shouldn't draw it. If I want to draw it, that's fine, but I'm going to have to put some x's on it later. Right now, what I want to do is take these coordinates of the parent graph, shift them 2 to the left and 3 down, and that'll give me my final graph. So shift 2 to the left. So if you go 2 this way and 1, 2, 3 down, you will get to your new coordinate. And then if you shift this one 2 this way and 3 down, you'll get to that point right there. Then the next one, 2 this way, 3 down, 1, 2, 3. You'll be right there. This next one, 2 units, and then 1, 2, 3. You'll be right there on the x-axis. So our real graph starts at that coordinate and it shoots off in this direction, going up and to the right forever. But what's this beginning point right here? That's the coordinate -2, -3. So that beginning point technically comes from h and k, -2, -3. Are you with me? Kinda?
Yes.
All right. So the beginning point of a square root function will always be the hk value. Okay. So now let's talk about domain and range here. So what would the domain be? X is what? Is this graph to the left and to the right forever? Or is it just at a certain x value to the left forever, or at a certain x value to the right forever? To the right. So x is what? Greater than or equal to? -2. That's right. This coordinate, the -2, -3, has an x value of -2, and it's all on this side of -2. It starts at -2 on the x, and it's all on this side of it. So x is greater than or equal to -2. How about the k value, or the range? The range will be your k value. So you're going to say y is what? Say again? Greater than or equal to -3. And that's about it, guys. That's how we're going to be graphing these guys. You identify h and k, ignore h and k, get your coordinates, and then shift them according to your h and k. All right? Is that the only way to do it? No. But that's the way I want you to practice it, at least for right now. How about this guy? What could I identify? What's my h value? What's my k value?
1.
H is positive 1, k is
0.
0. So what does that mean? At the end of it all, I'm going to be moving 1 unit to the right and 0 units up or down. You're not moving them anywhere up or down. So after you identify h and k, what do you do?
X and Y graph.
Ignore h and k with the box and make an xy table. That way you end up using the same coordinates of your parent graph. And if you forgot, you don't have to memorize the coordinates, just do them over again. 0, the square root of 0 is 0, square root of 1 is 1, square root of 4 is 2, square root of 9 is 3. Plot those points, 0, 0, 1, 1, 1, 2, 3, 4, 2, and 9, 3. Now, I'm not going to draw it because I know that I need to shift every one of these coordinates where? 1 to the right. So this first point is going to go 1 to the right. Next one, 1 to the right. This one, 1 to the right. This one, 1 to the right. And I'm going to put all those in red. 1 to the right. And then I'm going to graph my red one. And this is my final graph. What did I do? Again, I identified h and k. I ignored h and k with the box. I got my coordinates to the box, to the parent graph. I shifted them according to h and k, and that's my final graph right there. You could erase the blue dots if you wanted to, or you could just leave them like that because you didn't actually graph it. What's the domain? X is what? Greater than or equal to 1. That's right. It all starts at the x value of 1. The beginning point is your hk, your 1, 0. So it all starts at 1 and it's greater than 1. So x is greater than or equal to 1. How about the range? Y is what? Greater than or equal to 0. Perfect. Again, here's your beginning point. It's at the y value of 0 and it's above 0, so y is greater than or equal to 0. So we've graphed all these different ones. We're going to stop right there. Tomorrow we're going to graph the ones with the different a values. Like this guy, it's going to get vertically stretched. The parent graph is going to get vertically stretched by 2. And right here, the parent graph is going to get vertically compressed by 1/2. We'll show both of those on this graph tomorrow.